Hello everybody, I'm going to be walking you through a question from the GCSE, IGCSE EDEXCEL Higher Paper 2 from January 2023. Pause the video, read through it thoroughly and have a go at it yourself. So over here it gives us some key details about this, the cone and the sphere. Over here it tells us that the base radius of the cone is equal to the radius of the sphere. So this and this are equal. It also gives us an identity here that the volume of the cone times by k, a constant, is the same as the volume of the sphere. And now it's asking us to show that the total surface area of the cone can be written in the form pi r squared and then that bracket over there. So the first thing we're going to do is going to have to look at the equation for a volume of a cone. I've got it down over here. So it's 1 over 3 pi r cubed. 1 over 3 pi r squared h. So volume of it equals 1 over 3 pi r squared h. And volume of sphere is 4 over 3 pi r cubed. So it tells us that k lots of the volume of the cone is the volume of the sphere. So we can write over here k lots of 1 over 3 pi r squared h equals 4 over 3 pi r cubed. Quickly expand that out. 1 over 3 k pi r squared h equals 4 over 3 pi r cubed. So we can do a bit of simplification here. We can cancel the pi, we can divide 3 by pi, and we can get rid of the r squared. That'll turn into r. And we can multiply it by 3. So that will be k h equals 4r. And now it's asking us to find. So first we're going to need an equation for the total surface area of the cone. So it says the curved surface area of a cone is pi rl, and of course the circular base is going to be pi r squared. So right over here. Surface equals pi r squared for the circular base plus pi rl. Okay, so we don't have any equations which tell us what L is, but we know that a cone, sorry for my bad diagram, it tells us that L is the slant height, tells us that H is the perpendicular height, and it tells us that R is the radius. So we can use Pythagoras to find out L in terms of H and R. So we can write down R squared plus H squared equals L squared. Therefore, L equals the root of R squared plus H squared. So we can substitute this into the equation for the surface area. So I'll write SA for surface area equals pi r squared plus pi r squared plus h squared. So of course the equation that is trying to get us to write the total surface area in hasn't got any h's within it. So that means we're going to have to use the equation we used, which gave us the relationship between the volume of the cone and the sphere, which is this one over here. We're gonna have to use this and write h in terms of r and k and substitute it into our equation for the surface area. So it tells us that kh equals 4r. Then we just divide through by k and we get h equals 4r over k. And now we're going to substitute this into the equation for the surface area. Plus, so we're going to substitute 4r over k in place of h. Questions like these usually require lots of algebraic manipulation to get to the answer. That's what we'll go through. I'll go through that with you guys. I'm going to expand the brackets out. 16r squared over k squared. I'm just going to put an arrow here. pi r squared plus pi r. So what we can do from here is that we can actually factorize the r squared out of we can factorize the r squared out of r squared plus 16r squared over k squared, like this. And this is just r squared times by this bracket, and the square root function applies to both the r squared and the bracket, so we can just root the r squared and we'll get r on its own. That's going to be pi r squared plus pi r squared lots of 1 plus 16 over k squared. So now this is the equation of the surface area still. We're going to factorize pi r squared out of it altogether. So that's something you can do. One lot of pi r squared here, and this surd, lots of pi r squared here, so it's going to be so still we're not quite there yet when it comes to having this form. So that tells us that a bit more manipulation has to take place. So we can leave this for now, we can focus on this bracket over here. We've got 1 plus root of, so one thing we can do here is that 1 is the same as k squared over k, so we can get rid of the 1 by writing this as k squared over k squared. I meant k plus 16 over k squared. That's going to be k squared plus 16 over k squared. And now from this we can factorize out 1 over k squared. Like that. So I've taken out the denominator and I've separated it from the numerator. And just as we did over here with the r squared, as in we removed it and then we square rooted it and we brought it out outside the square root function, we can do the same over here. The square root of 1 over k squared will be 1 over k, because the square root of 1 is 1 and the square root of k squared is just k. From this we get 1 plus 1 over k lots of root k squared plus 16 . We can write that as 1 plus root k squared plus 16 over k, and we can get rid of this 1 plus it because we know that the 1 is equal to k over k, so you can do k over k plus k squared plus 16 over k, which will give us k plus k squared plus 16 over k altogether within the brackets. So remember that this bracket is still being multiplied by the pi r squared here. I just focused on developing and simplifying the bracket. So we'll bring the pi r squared in front of this, so we'll write surface area equals pi r squared k plus root of k squared plus 16 over k. Now you're going to check if this is in the same form as the answer, which it should be. Yeah, pi r squared plus k squared plus k squared plus the root of k squared plus 8 over k, which is our answer is in the same form as that. That means a equals to 16, which is a constant that we were finding. Thank you for watching this video. I hope you find it useful.